students of the day. I am Dr. Onika Parmar and I welcome you all in today's lecture. Today we are going to discuss about multiplexer, demultiplexer and the varieties of multiplexer, that is 2x1, 4x1 and we will be discussing 8x1 multiplexer. In today's class we will give an introduction on multiplexer and demultiplexer, and I will also cover 2x1 multiplexer, 4x1 multiplexer and 8x1 multiplexer. Multiplexer and demultiplexers are essential components in digital electronics that enable efficient data transmission and reception. They come in various configurations including 2x1 multiplexer, 4x1 multiplexer and 8x1 multiplexer, each serving a specific purpose in data processing and communication. Let's explore these devices and their functions in detail. So, in today's lecture, we will give the introduction followed by the principles of multiplexers and demultiplexers. We will discuss about multiplexer, 2x1 multiplexer, 4x1 multiplexer and 8x1 multiplexer. We will discuss their truth table, their logic symbol and data selection for the particular multiplexer. We will also discuss about the conversions of multiplexers, that is 8x1 multiplexer using 4x1 and 2x1 multiplexer. So, let us begin this lecture. So, there are many applications, many devices or system need to access a common transmission medium. Let us consider some examples. In our cable TV system, in which multiple TV channels are received at home via a standard transmission medium. Similarly, in computer networking, many computers need to access a common printer or other shared hardware. In smart instrumentations, a PC or a microcontroller can acquire data gathered from many sensors through a single ADC is analog to digital converter. Our telephone exchange uses multiplexers and demultiplexers extensively for their work. Multiplexers and demultiplexers are normally used for sharing resources. Multiplexers routes the data from many sources to one destination and demultiplexer redistributes the data back from one source to many destinations. So, let us discuss about the principles of multiplexing and demultiplexing. The principles of multiplexing and demultiplexing will now be discussed here. So, let us consider a system with n input multiplexing, means many to one. Multiplexing stands for multiple input and single output. A multiplexer, also known as MUX, is a device that allows digital information from several inputs to be routed into a single line of transmission. This is shown in figure 1. So, this shows the principle of multiplexing and demultiplexing. Here we can see there is a input of n bits, that is n input signals are there in a multiplexer, and we can see there is a single channel at the output. So, what is happening here is the input data is selected which should be sent at the output of the multiplexer. Suppose the first line needs to be sent at the output. So, the selection line, we select the first line and will transmit it at the output. So, in the multiplexer there are n number of input and output will always be 1 no matter what. The output will always be 1 in the case of the multiplexer, while its opposite in the case of the demultiplexer. So, in the case of a demultiplexer there is one single input and we have number of various outputs. So, suppose there is a system, okay, and there is a multiplexing unit and a demultiplexing unit, and there is a transmission channel. So, at the transmitter end there is a multiplexer which selects which data to be transferred. It passes through the multiplexer and the data is taken out from the multiplexer, that is the output of the multiplexer, and it is being transmitted. Now, that data is received by the demultiplexer, it goes at the single line input and then it selects on which line of the output this input needs to be sent. That is, it does the process of demultiplexing. It judges to which output line this input data has to be sent. So, this is the process of a transmission and reception. So, when we are in those areas where multiple data are present and we have to have single selection, or there is single selection and we have to have which data to be sent at which channel. So, in those cases multiplexers and demultiplexers are used. So, the multiplex data is transmitted over a single line to a common destination. Demultiplexer accepts this data and redistributes it to the n outputs. Data select lines are used in many to one operation of the multiplexer and one to many operation for demultiplexer. In short, multiplexer and demultiplexers are combinational circuit designed to provide sharing of the resources. So, let us discuss multiplexer in detail. A multiplexer is a device that allows digital information from several sources to be routed into a single line or transmission over that line to a common destination. The basic multiplexer then has several data input lines and a single output line. It also has data selector inputs that permits digital data on any one of the input to be switched to the output line. A simple multiplexer can be represented by a switch operation that sequentially connects each of the input lines with the output as illustrated in the figure. So, here we can see there is a simple multiplexer operation going on, and what is done, the electronic component is switching the data from the input, that is ABC are the inputs, high, low and high, and they are switched one by one and the data is taken at the output. That means at first time A is received from the input and A is transmitted at the output. In the second time B is received from the input and it is transmitted to the output line. In the third time C is received at the input and it is transmitted at the output. So, we will get this kind of output pattern as shown in the figure. Now, assume that we have logic levels as indicated on the three inputs. During the time interval T1, input A is connected to the output. During the interval T2, input B is connected to the output, and during interval T3, input C is connected at the output. A multiplexer is a combinational circuit that has 2 to the power of n input lines and a single output line. Simply, the multiplexer is a multiple input and a single output combinational circuit. I repeat, it's a multiple input and a single output combinational circuit. The binary information is received from the input lines and are directed to the output line. On the basis of the values of the selection line, one of these data inputs will be connected at the output. Here, selection line plays a significant role in the case of multiplexer. Unlike encoders and decoders, there are 2n selection line and 2n out and 2n input lines. So, there is a total of 2 to the power of n possible combinations of the input. So, let us discuss about the 2x1 multiplexer here. So, this shows the block diagram for a 2x1 multiplexer. So, here we can see 2x1, that means 2 input line and 1 output line. There will be a enable line and there will be the selection line. The selection line will select either A0 or A1 will be given at the output Y. If the selection line is suppose high, then let's assume it's transmitting A0. So, when the selection line will be low, it will be transmitting A1. So, when the selection line is low, A0 will go at the output. Suppose 1 is present at A0, so 1 will be reflected at the output. Suppose the selection line is low, then in that case, let us assume 0 is present at the output. So, 0 is present at the A1, so 0 will go to the output. In a 2x1 multiplexer, there are only 2 input lines, A0 and A1, one selection line, that is S0, and a single output, that's Y. On the combination of the inputs which are present at the selection line S0, one of these 2 inputs will be connected to the output. The selection line plays a significant role in the case of the multiplexers. Selection line selects which data should be transmitted at the output. Let us understand this with the help of the truth table. So, the truth table for 2x1 multiplexer is given here. Here we can see the inputs are considered to be selection line, that's for S0 there are 2 possible combinations, 0 and 1, and at the output we take output at Y. So, Y will be A0 if the selection line is logic low, and if the selection line has logic high, then A1 will be transmitted at the output. The logic diagram for a 2x1 multiplexer is shown here. The logic expression for the term Y is given as Y is equals to S0 bar dot A0 plus S0 A1. The logic circuit for the expression is shown here. So, this shows the logic diagram for a 2:1 multiplexer, that is 2 input 1 output multiplexer, and here we knew Y is equals to S0 bar dot A0 plus S0 A1. So, A0 is connected to one of the AND logic gate and S0 bar is connected to the second terminal and the output is given to the OR gate. Similarly, in the second AND gate, the input is A1 and S0 and the output is given to the input of the OR gate, and the OR gate according to the combination selects which data to be given at the output. So, let us continue our discussion for 4:1 multiplexer. In the 4:1 multiplexer, there is a total of 4 input, that is A0, A1, A2 and A3, and 2 selection line, that's S0 and S1. We can refer it as S0 or S0, both are the same. So, S0 and S1, and the output is only single bit, that's Y. On the basis of the combination of the inputs that are present at the selection line S0 and S1, one of these 4 inputs are connected to the output. The logic symbol for 4 input multiplexer is shown here. So, there are 4 input lines, that is D0, D1, D2 and D3, and 2 selection lines S0 and S1, and there will be only single one data output. So, logic symbol for a 4 input multiplexer is shown in this figure. Notice there are 2 selection line, because with 2 selection bits each of the 4 data input line can be selected. See, 2 selection line will generate 4 number of combination, and their combination will decide which data to be given at the output. So, data selection for a 4 input multiplexer, if a binary 0, S0 is equals to 0 and S1 is equals to 1 is applied to the data selection lines, the data on the input D0 appears at the data output line. If binary 1, that is S1 is equals to 0 and S0 is equals to 1 is applied to the data selection lines, the data on the input D1 is appeared on the data output. If a binary 2, that is S equals to 1 and S0 is equals to 0 is applied on D2 is applied, and the data on D2 will appear at the output. If a binary 3, S1 is equals to 1 and S0 equals to 1 is applied, the data on D3 are switched to the output lines. So, a summary of this operation is given in this table. It gives the data selection for a 4 input multiplexer. So, here we have 2 selection line S1 and S0. So, there are 2 selection lines, so there will be 4 possible combination, that is 0 0, 0 1, 1 0 and 1 1, and input selected data would be for 0 0 it would be D0, for 0 1 it would be D1, for 1 0 it would be D2, and for 1 1 it would be D3. The data output Y is equal to the data input D0 if and only if selection line S1 is equals to 0 and S0 is equals to 0. That is, Y will be equals to D0, S1 bar and S0 bar. The data output Y will be equals to D1 if and only if selection line S1 is equals to 0 and S0 is equals to 1. So, here Y will be equals to D1 S1 bar dot S0. The data output is equals to D2 if and only if selection line S1 is equals to 1 and selection line S0 is equals to 0. Y will be equals to D2 dot S1 dot S0 bar. The data output D3 if the S1 is equals to 1 and S0 is equals to 1. So, here Y will be given as D3 dot S1 dot S0. So, the logic diagram for the 4 input multiplexer is the terms are odd. The total expression for the data output Y is equals to D0 S1 bar dot S0 bar plus D1 S1 bar S0 plus D2 S1 S0 bar odd with D3 S1 S0. So, this shows the implement of this equation in the form of the logic diagram. So, here we can see the combination of the selection line is given at the input for the AND terminals and data D1, D2, D3 and D4 are given to these AND terminals respectively, and the output of the AND logic is given as the input of the OR logic and the output Y is selected from here. So, let us discuss about 8x1 multiplexer. In a 8x1 multiplexer, there are total 8 inputs, that is A0, A1, A2, A3, A4, A5, A6 and A7. So, for 8 input combination, we will require 3 selection lines, that is S0, S1, S2, and for a multiplexer there could be n number of input, but there will be only one single output. So, let us say our single output is represented as Y. So, on the basis of the combination of input that are present at the selection line S0, S1 and S2, one of these 8 inputs are connected to the output. This shows the block diagram for a 8:1 multiplexer. Here we can see that 8 selection line from A0 to A7. There is a enable line, and for to get 8 combinations we have 3 selection lines S0, S1 and S2. So, these 3 combinations of the selection line will select which data of the input to be given at the single output. Suppose 0, 0, 0 is present as S1, S2 and S0, then A0 will be given to the output. 0, 0, 1 is present at the input, A1 will be given at the output. Similarly, up to A7. So, this shows the truth table of a 8:1 multiplexer. Here we have the inputs of the selection line S0, S1 and S0 and the possible combinations of them, and we have output. So, if we have 0, 0, 0 at the input, we will get output as A0. For 0, 0, 1 it is A1, 0, 1, 0 A2, 0, 1, 1 A3 at the output, 1, 0, 0 A4 at the output, 1, 0, 1 A5 at the output, 1, 1, 0 A6 at the output and 1, 1, 1 A7 at the output. So, the logic expression for term Y is given as S0 bar, S1 bar, S2 bar, A0, S naught S1 bar S2 bar A1 plus S naught bar S1 S2 bar A2 or S naught S1 S2 bar A3 plus S naught bar S1 bar S2 A4 S naught S1 bar S2 A5 S naught bar S1 S2 A6 plus S naught S1 S3 A7. So this is the logic expression for a 8:1 multiplexer. This is the logic diagram for a 8:1 multiplexer. Here we can see that there are the selection line and the not of the selection line, that's representing S2 and S2 bar, S1 and S1 bar, S0 and S0 bar, and these combination according to the logic expression are given at the input of the AND gate along with the inputs of our circuit, that's A0 to A7. So these are given according to the logic expression at the inputs of the AND gate, and the output of these AND gates are transmitted to the OR gate, and they act as the input for OR gate, and Y is taken at the output. So this is a combinational circuit. In the case of a combinational circuit, only present inputs come into play. So whatever will be the present input provided, will be the present input provided will have the possible combinations will be judged. So let's discuss a 8:1 multiplexer using 4:1 and 2:1 multiplexer. So we can implement the 8x1 multiplexer using a lower order multiplexer. To implement a 8x1 multiplexer, we will require two 4:1 multiplexer and one 2:1 multiplexer. So 4x1 multiplexer have two selection lines and 4 input lines along with one output line. The 2x1 multiplexer will only have one selection line, 2 input lines and one output line. For getting 8 data inputs, we will require two 4x1 multiplexers. The 4x1 multiplexer produces one output. So in order to get final output, so we will need a 2x1 multiplexer. The block diagram for a 8:1 multiplexer using 4x1 and 2x1 multiplexer is given below. So here we see there are two 4x1 multiplexer at the input end, and the 8 possible combinations are taken from these two 4:1 multiplexer, and the output of this 4:1 multiplexer is given to the input of a 2:1 multiplexer, and the data is taken from the output Y. So today we have discussed about the introduction and principles of multiplexing and demultiplexing, followed by multiplexer. In this we have discussed a 2x1 multiplexer, a 4x1 multiplexer and the 8x1 multiplexer. We have seen their logic symbol, their block diagram, the truth table along with the logic diagram for each multiplexer. We have also discussed about the 8x1 multiplexer using 4x1 and 2x1 multiplexer. We have seen how to design this 8:1 mux using 4:1 and 2:1 mux. So, thank you for attending today's lecture. Hope to see you in the forward classes.